Hello everyone, this is Anshka Gupta and welcome to my channel Let's Code and Solve by Newton School. I hope my last videos are being clear to you. Today we're going to study about what is data structure and what are the comparison of your data structure and configurations of that and types of it. So before going to that, let's know what is Newton School. So Newton School is a platform which prepares you for career in tech. It has courses designed for freshers, working professionals, and also for women with non-tech background. Newton School first trains you for 6 months and helps you to become amazing full-stack developer. It also has a network of more than 300 great companies who hires from Newton School. So once the training has been complete, Newton School also ensures that the students are placed in one of the best companies in the country. And the best part is the Newton School has a pay after placement program under which you don't have to pay anything to Newton School until or unless you have been placed with minimum 5 lakhs etc. Now let us surf towards the Newton School website. So here's the Newton School website. Here you can log in and sign up yourself. The top companies where you have been placed is 7-Eleven, MyShow, Rapido, Lenskart, TechMint, First Choice, and many more. Let's move to our concept about the introduction about the data structure and configurations of that. Now, moving toward what are the configurations of your data structure and the storage structure and what is the difference between that. Okay, so data structure and the storage structure both are being in relative different to each other, but still when you are being configuring out both of these terms, these are being given as in similar abstractions in that. So the logical or the mathematical model of a particular organization of data is in data structure, and the representation of a particular data structure in the memory of a computer is in storage structure. In storage structure, there are many possible storage structure to be a particular data structure in that. Example, if there are number of storage structure for a data structure such as array, it might have possibility of two data structure represented in the same storage structure in that, because in Python you have to remember, like, you don't have to explicitly state the type of your variable or your data. That is just because it is a dynamically typed data, and your dynamically typed data languages are languages which are being stored in a mutable form in that. So what are the classification of your data structure in that? One is linear, another one is non-linear. In linear data structure, it is said to be a linear because of elements form a sequence, or in other words that they are being linear list. Whereas in your non-linear part, the objects and your list are not they are not said to be set in a sum of sequence, and the words are not given in a linear list, so they are being called as a non-linear part. So representation in your memory, representation, the two basic representation of a memory they are, one is being having the linear relationship between the elements represented by the means of the sequential memory location, that is array. Another one is have the linear relationship between the elements represented by the means of pointer or links. That means that is non-list, that is linked list in that. So while performing the operation on linear structure, we have 6 types and operations, that is transversal, search, insertion, deletion, sorting, and merging. Now what is transversal in operation on linear structure? That is the processing each element in the list. Second, search. It means like finding the location of an element with a given value or record with a given specific key in that. Third is adding a new element to a list. Fourth, removing an element from a list in that. Sorting means arranging the elements in some type of order in that. And sixth is the combining two a list in a single list, that is the merging. Now, as we read about the arrays priorly also, and we know data structure having a probability, a way of organizing and sorting the data, so that can be assessed with a more of the more efficiently. These are being just a relationship between the data operations and your performed data in that any of that. So linear array is similar to that. A linear array is also a list of finite number of inhomogeneous data types or data elements. That is that data elements are of same type such that the elements are the arrays of that and represented as an index set by a number of n consecutive numbers. So the more the linear array are there, the more consecutively they will execute. Okay, and another part is the element of the array are sorted respectively in the successive memory locations and that. Now, when the number n of the element is called the length of or size of the array, the index set consists of the integer, that is 1, 2, 3, 4 up to 8, and the length or the number of data elements of the array can be obtained to form the index set by length is equal to upper bound minus lower bound plus I. Okay, where UB is an largest index called upper bound, LB is the smallest index of the array in that. So here the linear arrays and the length of the number of data elements are being formed by the index number. Now, element of A may be denoted by the subscript notation, parenthesis notation, and bracket notations. They're just subscript we use similarly A1, A2, A3, or in the foot part of your alphabets, and the parenthesis notation, that is the parentheses are being given to represent the number of elements in your bracket, circular brackets in that. Bracket notation similarly to the parenthesis, but that is in your that is in your square brackets. Okay, the number k is the number k in AK is just in subscript. Okay, and or the index of your AK, that is called subscripted variable in that. Representation of your linear array in a memory that are been given as a proper value that has been defined either as an increasing or decreasing or a computer memory in that allocations of your computer memory. Now, how we represent our linear array in a memory? For that, suppose LA be a linear array in a memory of a computer, and you have to address an element. So you will be writing a formula of that LOC LA K is equal to address of your element LA K of array LA. Okay, the element of LA are sorted as in successive memory cells. Computer does not need to keep a backtrack or track of elements of every element of LA, but you need to have an address of first element array to sort out the base called the base address of your LA. Now the representation of your linear array in your memory, how you represent the linear array in the memory, that is the LOC base LA plus WK minus lower bound, where W is the number of words per memory cell. Just remember one thing, when you have a various kind of data structure defined, that makes actually it is easier, but you have to remember that getting the loss in the details, that will be lost to you. Okay, because it is not a beneficial part where your memory allocations are being given in the particularly era and that. So here's an example one where you have to present the address of each element. So here the address of each element is being done by the bracket notations LA, LA2 in a square bracket, and each of them has the value of address. Suppose the base value is 200. Okay, so base value 200 into the array differences of 1. Okay, now k is out of the k, the total number of addresses in that we have given as a LAK, and minus the lower bound has to communicate in that. So here the output will be 205. Okay, same the example is there for calculating the LA of 16. So similarly to that. Now how the representation of your linear array in a memory given, similarly to that, as an LA LK, the subscripted part is being used, and the collection of A of your data elements is said to be indexed if any of your element of A called AK can be localized or processed in the time of independent of K. Now transversing of your linear array. So transversing of your linear array is being configured out where where your point has been given or not, but that is what you actually have to perform in that. I hope it has been clear to you how you've been understood the area definitions of the configuration. Thank you for watching my video. Like the video, subscribe to my channel and stay tuned.